In this video, we're going to look at solving exponential equations. Let's begin. In many problems involving exponentials and exponential equations, the secret is to convert everything to a common base. So, as an example, let's assume you're given the equation 2 to the power of x is equal to 32, and you're asked to solve for x. So the first thing to do is try to convert this 32 into the same base as the exponent. So you may know that 2 to the power of 5 is 32. 2 times 2 times 2 times 2 times 2 is 32. So we can now write this equation as 2 to the power of x is equal to 2 to the power of 5. And simply by equating these exponent terms now, we can say that x must be 5. Very simple example of how to match the bases. Another quick one involving this time a negative sign. If we have negative 4 to the x, and the negative sign is inside the bracket, so it's impacted by the exponent, and we're told that that is equal to minus 1024. So we've got a negative sign here, and that gives us a clue that the exponent x must be an odd number. Otherwise, the minus signs would disappear. So, converting to a common base, 4 to the power of 5 is 1024. So if we do negative 4 to the power of 5, we will get negative 1024. So again, equating the exponents on each side of the equation, now that we have matched the bases, we find that x is equal to 5. Okay, let's look at a slightly more complicated example now. Example 3. In this case, we've got a little algebraic expression sitting up in the exponent. So 5 to the power of 4 minus 3x. And we're told that that is equal to 25 to the power of x plus 1. Same approach. We notice that we have two different bases, 5 and 25. But we know we can write 25 as 5 squared. So let's do that. So this is 5 squared, and then that 5 squared is raised to the power of x plus 1. Now, we can't yet match up the exponents because we have a power to a power on this right-hand side. And so we need to take care of this power to the power expression. And remember from your exponent rules that if you have a power to a power, you simply multiply those powers together. So this is 5 to the power of 2 multiplied by x plus 1. We can expand that bracket, 5 to the power of 2x plus 2. That's simply by distributing this 2 into the bracket. Now we have on the left-hand side 5 to the power of 4 minus 3x is equal to 5 to the power of 2x plus 2. Now we can simply equate the two exponents. So 4 minus 3x must be the same as 2x plus 2. So we have a simple linear equation to solve. We'll take away 2 from both sides, and we'll add 3x to both sides. We'll end up with 2 is equal to 5x. X is equal to 2 divided by 5. Let's look at a slightly special case. Suppose you're told that 3 to the power of 3x plus 1 is equal to 1. Now, in exponent problems, the number 1 is a special case. You'll remember from your exponent rules that anything to the power of 0 is equal to 1. Pi to the 0 is 1, 10 to the 0 is 1, 3 to the 0 is 1. So that basically means that we are free to write the right-hand side as anything we like to the power of 0. And obviously here we're trying to match bases, so we would like 3 to be our base. So we can write this as 3 to the power of 0. And now we've got the same base on both sides, so we can write that the exponent on the left side must be equal to the exponent on the right side. And therefore 3x is negative 1, and therefore x is negative 1 divided by 3. So watch out for that when you are given a 1. Remember that particular exponent rule. Now it might be necessary to manipulate both sides of the equation to get a common base. For example, 4 to the x plus 5 is equal to 8 to the 1 minus 3x. Now here we cannot write 8 as a power of 4, but we can notice that 2 could be a common base because 4 can be written as 2 squared and 8 can be written as 2 cubed. So if we substitute in those values, we get 2 squared on the left side raised to the power of x plus 5. And on the right side, we can write the 8 as 2 cubed, and it is raised to the power of 1 minus 3x. Now, we still don't have a common base yet. We've got 2 squared on this side and 2 cubed on this side, so we're going to use the power of a power rule, and we're going to multiply these two exponents together. And similarly over here, we're going to multiply these two exponents together. And that will give us 2 to the power of 2 into x plus 5 is equal to 2 to the power of 3 into 1 minus 3x. Distributing those brackets, once we have written down the equality, so the exponents are equal to each other. Now I can expand. 2x plus 10 is equal to 3 minus 9x. Gather up the like terms. I've got 11x on the left side, and I've got minus 7 on the right side. So x is equal to minus 7 divided by 11. Okay, you might come across cases where you need to use a negative exponent. So let's say we have 7 to the power of 3 minus x is equal to 1 divided by 49. So we're looking to establish a common base, so we'd like to write this expression on the right-hand side as a power of 7. So we can certainly write it as 1 divided by 7 squared. And that's the same as 1 divided by 7 all squared. And now remember that you can turn a fraction upside down if you change the sign of the exponent. In this case, we're going in the unusual direction of introducing a negative exponent, but that's because we're trying to match the bases. So we'd like this right-hand side to be a power of 7. So we're going to turn that fraction upside down, and we're going to change the exponent to a negative. And that is simply 7 to the power of negative 2. So we've ended up with 7 to the 3 minus x is the same as 7 to the negative 2. And now we can equate those exponents. And now we can gather up the like terms, and x is equal to 5. Okay, slightly more complicated example with a fractional exponent. 9 to the power of 2x plus 3 is equal to 27 to the x divided by 4. Now, don't panic. Again, we're still trying to match bases. We can't write 27 as a power of 9, but we can write both of these as powers of 3. 9 is 3 squared, 27 is 3 cubed. So let's do that first of all. So we've got 3 squared all to the power of 2x plus 3 is equal to 3 cubed to the power of x divided by 4. Now we've got powers of powers, so we're going to multiply these two exponents together, and similarly on this side. So what do we get? 3 to the power of 2 multiplied by 2x will be 4x. 2 multiplied by 3 will give me plus 6. And on this side, I've got 3 to the power of, now I'm multiplying 3 by this fraction x over 4. Don't make the mistake of multiplying the top and the bottom. That'll have no effect whatsoever. So 3 multiplied by x over 4 really means 3 over 1 multiplied by x over 4. And so we multiply the top and we multiply the bottom. So you get 3x over 4. Now we've matched the bases, so we can match the exponents. So 4x plus 6 must be identical to 3x over 4. To get rid of this fraction on the right-hand side, we multiply both sides of the equation by 4, so we'll get 16x plus 24 is equal to 3x. Take away 3x from both sides, 13x is equal to negative 24. And therefore x is equal to negative 24 divided by 13. Another problem you might come up against is where you need to actually factor the exponents to solve the equation. So an example of that would be 2 to the power of x plus 4 plus 2 to the x is equal to 136. So what does this really mean? This term on the left here, if you're raising something to the power of two things added together, remember adding exponents is the same as multiplying the numbers. So this is really 2 to the x multiplied by 2 to the 4 plus 2 to the x is equal to 136. Now by breaking that exponent apart, we've now got similar looking things. We've got a 2 to the x here and a 2 to the x here. And that enables us to factor the left-hand side of the expression. So I can pull out a common factor of 2 to the x. And what I'm left with, this will give me a 2 to the 4. And here I just got one lot of 2 to the x is equal to 136. And just, if you're not confident with pulling out common factors, just go backwards and make sure that when you expand the bracket, you get the original expression. So 2 to the x times 2 to the 4 gives me this first term, and 2 to the x times 1 gives me the second term. So this is correctly factored. And now that enables me to isolate 2 to the x by dividing both sides by 2 to the 4, which is 16, plus 1 is 17. And 136 divided by 17 is 8. So 2 to the x equals 8, and therefore x must be 3. So be aware of that type of problem where you need to factor. Here's one more of those just to give you a bit of practice. Suppose we have 7 to the power of x plus 1 plus 7 to the power of x plus 2 is equal to 392. So again, because we have an expression with a plus, we can break each term into a product. 7 to the x plus 1, if you're adding powers, that means you are multiplying. So we have 7 to the x multiplied by 7 to the 1 plus 7 to the power of x multiplied by 7 to the power of 2 is equal to 392. Again, we can pull out a common factor of 7 to the x, and we're left with 7 to the power of 1, which is just 7, plus 7 to the power of 2, 7 squared is 49, is equal to 392. And now we can isolate the 7 to the x as 392 divided by 56, which is 7. So 7 to the x equals 7, and therefore x equals 1. Two more examples just to take the level of complexity up a little bit and make sure you're prepared for whatever they throw at you. 8 to the power of 2x divided by 4 to the power of x minus 1 is equal to 2 to the x plus 1. Now, it looks a bit daunting to start with, but notice that each of the exponents, or sorry, each of the bases, I should say, is a power of 2. This is 2 cubed, this is 2 squared, and this is 2 to the power of 1. So we can modify this expression to be exclusively powers of 2, and that will enable us to simplify and solve. So let's do that. So what we've got is 2 cubed to the power of 2x divided by 2 squared to the power of x minus 1 must be equal to 2 to the x plus 1. Now on top over here we have a power of a power, so we know we have to multiply those together, and similarly on the bottom, the power of a power can be simplified by multiplying the exponents. So we end up with 2 to the 6x divided by 2 to the power of 2x minus 2 is equal to 2 to the x plus 1. Now, exponent rules tell us that if we're dividing two exponents with the same base, we simply have to subtract the exponents. So this left-hand side where we have division, we can write it as 2 to the power of, subtract the exponents, so we've got 6, take away 2x minus 2, keep the bracket so that we don't lose a minus sign. We're going to simplify that into 2 to the power of 6x minus 2x, and then we have minus 2, and that gives us plus 2, which again we can simplify to 2 to the 4x plus 2. And now these two give us path to the solution. So we've got 2 to the 4x plus 2 must be equal to 2 to the x plus 1. And now we can simply equate the exponents. 4x plus 2 is x plus 1. Take away x from both sides, we get 3x. Take away 2 from both sides, we get negative 1. And therefore x is equal to negative 1 divided by 3. The last example for this video, again slightly more complicated, 8 to the power of 1/4 multiplied by 1/4 to the power of x over 2 is equal to 16 to the power of 3/4. Now again, that at first sight in an exam environment looks pretty scary, but the thing to notice is that all of these bases, 8, 4, and 16, can be expressed as powers of 2. So 8 is 2 cubed, 4 is 2 squared, and 16 is 2 to the power of 4. So we can rewrite this as 2 cubed to the power of 1/4 multiplied by 1 over 2 squared to the power of x over 2 is equal to 2 to the power of 4 raised to the power of 3 over 4. Now we can use our exponent power rule. We've got power of 3 and the power of 1/4. So to combine those, we simply multiply them. So we're left with 2 to the power of 3 over 4 multiplied by, now what's going on here? We've got 2 squared on the bottom of a fraction. We can turn that fraction upside down if we change the sign of the exponent. So 1 over 2 squared is the same as 2 to the negative 2. Just turning the fraction upside down and making a negative out of the exponent. And on the right-hand side, we have a power of a power, so we multiply those together. 2 to the power of 4 raised to the power of 3 over 4. 4 times 3/4. The 4's cancel, and we're simply left with 3. So we're getting close now. We've almost got everything written as a single exponent. 2 to the 3 over 4 multiplied by, now we still have a power of a power in this second expression, so we'll multiply those together. We get 2 to the minus x. The 2's cancel, but we still have the minus sign, is equal to 2 to the 3. Now be careful with this next step. We've got 2 exponents multiplied together with the same base, and our exponent rule for multiplying says that a to the m times a to the n is a to the m plus n. So here 2 to the power of 3/4 multiplied by 2 to the power of minus x is simply 2 to the power of 3/4 plus negative x, so minus x. Don't be tempted, some people might be, to multiply these two together because they see a multiplication sign here. Remember, we're dealing with exponents, so when you multiply, you add the exponents. So we're almost there. 2 to the 3 over 4 minus x is the same as 2 to the 3, and now we can finally equate the exponents. 3/4 minus x must be the same as 3. Take the x to the other side, and we get 3/4 minus 3. And therefore x is equal to negative 9 over 4. Okay, that concludes this video on exponential equations. In the next video, we'll look at exponential growth and decay word problems. If you've liked this video, please click like and subscribe, and then you'll receive notification of when new videos are posted. Thank you very much indeed.